Hey guys, welcome back to the channel. Today I'm going to be covering a much requested video topic, which is how to use 3D scanning to develop products. And today I've got the perfect project just for that. If you're unfamiliar with my channel, this is my 2JZ RX-7 FC drift build. And one thing that I'm still lacking on this car is an oil catch can and a coolant overflow reservoir, which I'll be putting right here behind the passenger side strut tower. So to do that, first step is to 3D scan the surface. Now let's talk about the 3D scanner that I'll be using. This is a RevoPoint Range 2, and it's pretty simple to use. It's pretty cheap. You can get them for like $550 on Black Friday or around $600 maybe. They're pretty cheap scanners. I'm not sponsored by these companies, but I do have two of their scanners. I've previously used a peel scanner, a ferro arm. I've got a lot of experience with scanners, but for my home use and my small business use, I've steadily relied on the RevoPoint to get everything I need done. Because primarily for 3D scanning, I'm not trying to scan something and reverse engineer it. I'm trying to scan something to establish a space claim so that I can design around it. That's just the type of products that I'm typically designing. I'm not typically designing something to directly copy it or copy the geometry to create the model for it. All right, so setting this thing up is pretty simple. You can use your phone. I typically like to use my laptop instead. It's just got one main cable on the back side. All right, first things first, let's go over the RevoScan 5 software real quick. This is a free software you can download on their website. And I go to the top right, hit new project, 3D scan, and this is gonna be for oil catch can. So now on the top right, you can see that we're connected to the scanner. You can see what the scanner can see right now. And I'm gonna keep this pretty quick and simple. There's other videos out there showing how to use this software, but I'll show you my current settings. So I like to keep it in high accuracy. I leave it in feature tracking. I don't have a lot of success with this scanner with marker tracking. That's the either magnetic or stick-on dots. And object type, I usually have the most success with dark. I do not do color scanning, it's a waste. And you can adjust your scanning distance down here. We're doing something a little bit smaller, just the corner of the engine bay, so we'll bump that down a little bit. And if you're unfamiliar with the software, you can read every single thing here with the little information icon and figure out what you want to do. But, so I think that's good enough for the software overview. We're gonna click Start to Scan and hop over to the engine bay. And real quick, on the back side of the RevoPoint, we have a few buttons. We've got the start button in the center, and then we have minus and plus. So plus and minus adjusts the exposure of the depth camera up top. So I accidentally just hit start, but you can see the blue on the depth camera exposure and then the red. So the goal is to try and hit that middle ground. You don't want red and you don't want blue. You just want to be, have enough exposure to capture what you're doing without overexposing it and losing detail. So let's hop over to the car and we'll get this thing scanned. All right, so you can see we're fully set up here. I've got the software running and scanner ready to go. One thing I haven't done is I haven't prepped this corner using a 3D scanner spray. I typically do use it. This is kind of glossy, so it might struggle a little bit, but I just got done painting this whole engine bay. I don't really want to mess with wiping that stuff off. And I only have the orange cap version, which doesn't evaporate as easily, so you do kind of have to wipe it off. But let's just see how this goes. First off, you can see the exposure of the depth camera is underexposed. We have a ton of blue, so I'm going to keep pushing the plus button to bring that exposure up. And you can see how the main screen is starting to improve and capture more detail. So I'm going to take one pass starting in this corner. And I'm going to choose this corner here because of the geometry. And it seems like it's something I can maybe come back to pretty easily and have it pick up and have good tracking. So let's just do one clean swipe of this corner here. So I pressed the play button, and I'm just going to come backwards slowly. And if you need to, you can adjust the exposure as you're moving. So now if I go to the top side, you can see that there's some blue there. I'm going to bump up the exposure a tad. And we'll call that good. Okay, so I just press the play button again to stop it. You can see what we've got captured so far. Got that top of the strut tower pretty well. You can see the firewall is decent. And now we're just going to work on capturing some of the little details down below in that corner and then the back side of the strut tower. To do that, I'm probably just going to hop on the lift real quick and capture it from the back side here. Okay, so we got a lot of red. I'm going to bump down the exposure a bit, press play, see what we can see. All right, so tracking looks good. Nice and green. You can follow that bar on the right side to tell you if you need to back up or zoom in. That can be helpful sometimes as well. All right, so we're definitely overexposed here. Let's bring this thing down. See if we can capture the backside here. All right, let's jump down. See how this looks. So we've got most of the backside captured. We've got our max height location right here. If you can see my mouse, it looks like that's something we'll want to avoid. And we've got a good view of this piece here, which has a couple bolt holes in it. And I think I'll try and do one more scan from the front of the car and call that good. All right, that's it. So now let's dive into how we can make this thing pretty and cleaned up so we can use it. All right, we're now set up in my basement, working off of my PC for the cleanup of the scan and orientation and moving on with modeling. So as you can tell from the scan, it didn't turn out super great. We've got a bunch of floaty stuff. I am missing a little bit of data I thought I had back here, but it shouldn't be a big deal. Big thing was capturing this bolt hole here, which looks okay. And just knowing that we have enough of this back side of the strut tower to kind of know our limits. So right now we have a poly. So this is just a bunch of points. It creates this large point cloud. And while it's in its point cloud stage, what we're going to do is go to isolation so we can detect all of these little isolating, blobs that just showed up. And while this looks like crap right now, it'll actually turn out pretty good. So isolation rate, we'll just start with what we've got here, 37%. And at 37% isolation rate, it's capturing pretty much all of the junk that we don't want. So hit apply, and I am good with that. So let's go to overlap detection. So this identifies any overlapping points within that point cloud. And if you have a really large overlap distance, you're not going to pick up as much as you would if you had really small ones. So we'll just try something in the middle, and it didn't pick up much, but that's fine. So we are now, if you look at the bottom left, at 421,000 points. That's not that many. Typically, a laptop can handle about 1 million points and still be, capable of modeling within it. I try to stick around under 2 million just to have a little bit better workability. And then there's also simplifying that you can do afterwards to bring those points down. But from here, I'm going to call this good, and we can maybe chop off some stuff before we mesh it. So if I just give it a quick orientation from the top view, come over here, this is how we can do our lasso, our polygon, and rectangular section. So if I want to take a quick rectangle out, just delete that. And same for this guy here. And now we've got more of just a clean, smaller amount, and we've reduced our point cloud size. So let's do one from the front. Make this thing a little bit more square. All right, that gives us everything that we need. So let's go ahead and mesh. So now we are meshing all of those points into surfaces. And what I like to do here, if you bring this grid size to be too large, you're going to end up with a really chunky, ugly setup. I typically try and max this guy out. Use a really small grid size to provide the most high quality scan result of the mesh that I can. And if that ends up being too much, then you can always go back and you can simplify the scan down and kind of do the same thing later for post-processing. So this is what we've got for our final mesh. I'm a little bummed that I missed the backside of this thing, but it should be fine. I think this would have turned out a lot better if we would have sprayed it with some of that 3D scanner spray. People always talk about using baby powder too, or foot powder, but really we got what we needed. We established our space claim to be able to model around. We know our pickup points here and here. We know our pickup point right here for bolt hole, and we know our high points down in this cavity to avoid with our oil catch can and coolant overflow tank. So let's go ahead and follow my next step, which is to chuck this into Blender and orient it, because I'm not super familiar with how to orient this thing properly within RevoScan. I don't feel like it's super user friendly, and there's also a cool little trick in Blender I'll show you guys, so let's hop over to that. Actually, there's one more important thing I forgot to show, which is exporting. So I'm going to export the mesh as an OBJ. Okay, we're now in SolidWorks, my CAD software of choice. This is SolidWorks 2024 Premium, and I paid a pretty penny for it. It costs a lot of money to have a proper SolidWorks license when you are using it for business. That being said, you can get SolidWorks for like 50 bucks in the Maker Edition. So highly recommend checking that out. I don't know what capabilities it has compared to what I have, so take that for what it is. One of those features being scan to 3D. So for a 3D scan, there's a couple ways of importing, and I'm still trying to find a better way, to be honest. The first way that I'll show you is just by doing a standard file open, go down to your scan, and you go to options. Within the options tab, you have solid body, surface body, and graphics body. The 3D scan will not open, at least in my case, for solid body and surface body. It will only open as a graphics body. So if I show you what that looks like, this is how SolidWorks brings in a graphics body. It is just one big blob. It's just one big box. I'm not able to pick up on all the points. If someone knows how to do that, I'd love to learn, because importing a graphics body is the only way that I've found that I can really apply cool appearances and make it really easy to work with. Especially when you come over here and you change it to shaded, it just free floats awesome. It does not, bog down my laptop or especially the PC. you can add your graphics to it or your appearances really easily to it. So I can just drop my favorite one, which is aluminum powder coat. It adds a nice little texture on it, and you can come up here and change the appearance so that it applies coarser or finer looking grain to it. It just helps kind of clean up the chunkiness of the scan and make it look legit. So that is option one. And the big downside of this is that there is no ability that I've found to add my planes. So when I add a plane, it just wants to attach to the entire body. I can't pick up on individual reference points. So I typically import it as a graphics body if I just want to take a finalized product and chuck it in and do renders and just have an easier working assembly. Now, the other way is I have the tab for SolidWorks add-ins and Scan to 3D. Not every version of the software has Scan to 3D, but if you do, you come up to File, Open, and you'd hit your drop down in the bottom right, and you would click on Scan to 3D Mesh Files. And from here, we can open up Blender, or the Blender version of that file. As you can see, this imported a little bit differently, and it is a lot more weighed down for me. I can feel it slows everything down. Again, coming up to here, changing it to shaded helps that a bit, but it's still, I can feel slowed down, especially with my space mouse. It struggles a little bit more. So here, the blue, you can see what I had scanned. This color on the back side is just everything that wasn't a direct, from the 3D scanner face. And you can see I got something going on here with errors. So feel free to reach out if you got some solutions here. But this way, I can now go and add some planes. So when I go to plane, I now have that yellow little dot indicating that I'm picking up on all those vertices here or the peaks of the mesh. So that's important for me to be able to start modeling my brackets to attach the oil catch can to the backside of strut tower. So I especially need a plane, back here. So I'll just knock out a little guy here. And I'll want maybe one plane right here because I've got one tapped hole in the body already. Close enough. And we'll do one more right here. Maybe so we can kind of establish a square face to how we want our part. And that didn't work very well. Let's try it again. There we go. Okay, so we have 3 planes for areas that we're kind of focused on. So from here, because this Revel Point range software does not have the ability to go in and add planes to it and cylinders and other cool stuff like a Peel 3 scanner would, for example, that software is amazing. If I wanted to go pick up on a hole, I could very easily. In this case, what I'm going to do is I'm just going to go to my plane 2 and I'm going to create an extruded boss. So my camera's not set up super great lighting wise to be able to see what I'm doing. But what I would do is I would come here to perimeter circle and I would click on 3 corners that make me feel confident that I have a concentric, sketched hole to what's there in the mesh. So you can tell I'm a little bit off there, but for example's sake here, we'll just extrude this guy out. And now You can see that's pretty off. Something happened here. Oh, look at my plane one, or my plane two. My plane two got off. So I'll go redo that again, but that's essentially the principle of it, is to create a plane on a surface that you scanned and then create actual extruded geometry so that you can go mate other pieces to it. So you get the gist there. I'll go back and fix that here. And I'll probably do the same on this face here and pick up on these two holes that you can slightly see. I must have just missed a point here or something to have that plane messed up, but I'm going to go ahead and fix some stuff and we'll be back. Well, I'm going to throw a curveball at you guys. I ended up swapping out the 3D scan for a previous scan that I forgot I had done a long time ago before I'd painted the engine bay. Hence all the tape and other stuff that you can see in this. But it does show how much better the scan can be when you use the 3D scanner spray. And I wanted to show a little bit cleaner model and um, get a little bit of that space behind the strut tower that I'd missed. So this is what we're working with. Same exact principle, same process. I did get these two boss extrudes put in, and that's kind of where I started to figure out how to get a square face off of the back of the strut tower and start establishing space claim. I keep talking about space claim. That's all I do with 3D scans, and that's how I, begin the modeling process. So I am figuring out the space claim for the two boxes, the oil catch can and the coolant overflow tank. So that's what this is here. I've got the coolant overflow tank attached to the backside of the strut tower, and then the larger 2-liter volume oil catch can next to it. And I got them in different sizes because I needed to stay away from this wall here, which has the windshield wiper motor that sticks out a little bit. So I'm using up as much space as possible while still leaving some clearance underneath so that I'm not hitting any of the bottom part of the engine bay there. And I ended up coming up with a couple different mounting points. These are a little bit variable. They can be adjusted a bit on the can. It'll be, this isn't a perfect edge, but a lot of this can be kind of figured out once I'm welding it all up. And this is just one M6 hole in the body that's already there, and then this will have to be like a nutsert or something to add an additional point. So now let's jump super far forward and show you what I came up with utilizing these two boxes to establish my geometry. So if I hide these two overflow mock-ups, I can show you guys the water tank and the catch can. So this is just me taking the exact geometry and creating sheet metal parts out of them. And you can look up how to do that stuff with various sources on YouTube. Everything you need to know about SolidWorks can be found on YouTube. You do not need to have an engineering degree to do this. So let's dive into each one individually, starting with the coolant tank. So this guy, gotta unhide this stuff here. So I've got a Amazon fill cap. This is a McMaster sight glass, 6AN to bring water into the tank, and got a little tab and slot action going on up here. I've never used tab and slots for any aluminum tanks or any aluminum parts in general, just because I usually am a little bit concerned about how to get a good solid bead across something with these big tabs sticking up there. So we're going to try this out and see just how much it interrupts the weld. But yeah, pretty simple. I will go into detail about one part real quick regarding SendCutSend. So that's who I'm using to create these parts. They will laser cut and bend and do PEM hardware insertion for all of these. And one thing that I like to do is I like to, when I do my sheet metal, is make sure that I set up my sheet metal parameters here. You set the bend radius to what it says for the material thickness on SendCutSend's website, and you set the K factor. You get those two things right, and this will come out exactly as it is bent at SendCutSend using the exact dies that they use. So it's a small thing that can hold you up in the submission process if you get it wrong and end up having some weird issues, or your flange length ends up not being exactly right. But little thing to think about when you're submitting your SendCutSend order. All right, let's move over to the oil catch can. So accidentally opened this one. This is an oil catch can version of the coolant tank. Same geometry, but that's the wrong one that I opened. Let me go back. So the assembly 3 is our oil catch can. I get lazy and I do not do a very good job naming all of my feature trees and all my parts. So I've never designed an oil catch can before, but looking at a lot of examples on Instagram and a few forums, just trying to figure out what quantity is good for volume. 2 liters is what this thing is, almost exactly. And I'm going to show all the nitty-gritty details that everyone hides. And this is what I got. So oil will come in through here. Left all this empty so that it can't splash into any of this cavity on the left. Nice slots here for oil to travel through. I've got an oil drain. This is true focus fab fitting that I measured up and tossed in there just for geometry's sake. And true focus fab 10AN fittings up top. McMaster sight glass. And oil will travel through this channel up here, just leaving some little gaps on the sides. And then to a plate here that's a little bit overly designed for a foam filter to vent to atmosphere. And then I've got a cover plate on top of that. And this is the PEM hardware here that SendCutSend will press in. So that's it. We're gonna go ahead and I think get all this stuff ordered from SendCutSend. And once that big order gets here, we'll start welding it up. Spend 6 days. That's all it took for SendCutSend to accept my files, laser cut, bend, and do PEM hardware installation and ship it to me. So over a holiday even, before New Year's. So let's get this thing unboxed and check out what we're working with. So everything showed up just as we ordered it, plus a few spares actually. So one thing SendCutSend does occasionally is if you order a quantity of one and it requires bending, they'll sometimes just add an additional laser cut part to the queue or to your order, just in case something happens and it gets bent incorrectly. That way they can just correct the mistake immediately right there and move forward, versus spending extra time and money recutting it and adding it to your order and holding your whole order up. So got a couple of bonus parts there, and like I mentioned in the SolidWorks overview, I tab and slotted everything, and this isn't quite the most thorough way to tab and slot, but I really just wanted to make sure I could cover the whole edge with one nice seamless bead. So we're gonna see how that works out. And next I'm just gonna start deburring. SendCutSend does have a nice deburred finish in the flat pattern, but I'm gonna hit all the corners and hit everything with acetone and just start getting it prepped for welding. So one other thing I want to talk about is the fittings now that we've got those in. This is the same McMaster sight glass that I ordered. The True Focus Fab fittings are awesome. This is the drain plug here, and they're 2 AN, 10 AN bungs for the oil catch cans. So, and just an Amazon special filler neck. Still not sure where I'm going to be setting up the overflow fitting, because when the while this is a coolant overflow tank, it also needs its own way of overfilling. You don't want to have, the pressurized system. You need a way to bleed it off if it overfills. So I think I'm gonna do one of these 3 fittings to try and tuck it on the side or maybe underneath. I'm not really sure yet. We're gonna see where I've got room, but let's start welding. All right guys, unfortunately, I made a boo-boo and it's gonna cost me another $50 sight glass. So what happened was I threaded this on, put my nut on the back side and locked the orientation the way I wanted it, and then took the sight glass off because this plastic is not heat resistant. It cannot handle the heat of TIG welding. And so I just tacked the back side of this nut and then tried to thread my sight glass back on, and it's completely gummed up. It probably warped. I don't see anything that looks like warping, but it's a washer with like 2 threads, so any slight discrepancy is going to cause it to gum up. So trying to figure out my path forward here for the coolant tank, because the oil catch can is now gonna need some rework. I'll have to cut my tabs or my tack welds and order another sight glass. And for the coolant tank, now I have a couple of options. I can either put my sight glass in first and then just leave the rubber washer on there and tighten this nut up and then call it good, and then continue to weld all of the outside panels to it. Or I can attempt tack welding it again with the sight glass in it and hope that I don't melt the rubber or the plastic here. So I think I'm not gonna risk it, and I've used this sight glass before for another tank and I was able to put my hand all the way in to tighten the nut. That tank hasn't leaked at all, so I think I can trust it. I'm just going to leave the sight glass attached to it, crank her down by hand, and then weld everything up around it, and we'll see if it leaks, but I'm pretty confident in that. There's just no serviceability is the only problem. You couldn't just take the sight glass off, so that's a bummer, but lesson learned. We'll attack this a different way and see what happens. So I got my sight glass put in there, all tightened up, and then tacked the outer shell. I'm really happy with the choice in tab and slot. I've never done the half style like that, but it makes for super easy tacking and just folds over real nice. So yeah, let's get this thing welded out. So let's talk about my TIG welding setup real quick. This is a CK Worldwide 17 torch with a number 7 cup. Usually how much gas you run is double the cup size or a little bit more. I typically stay on the heavier side. And I'm running 2% lanthanated, the blue tungsten for aluminum. And I usually run the laser for mild steel, stainless, and titanium. And then this, I get a lot of questions about this. This is my tungsten grinder. I modified this 3D printed file from Clow42 on YouTube. It's a free file, works for a Milwaukee rotary tool, and you just put these cheap diamond discs in there from Amazon. It's a really cheap combo, well worth doing. And the TIG welder I'm using is an Alpha TIG 203. And so on my settings, I'm using the pedal, high frequency, and my pre-flow 0.6, post-flow 5, start amps 25, end amps 20. My frequency is at 120, my balance is at 25, and then my amperage is at 135. And that's kind of irrelevant because I usually go really heavy on amperage so that I can dial it back. So I'll ramp in with the pedal kind of heavy so that I can get that puddle flowing and I can fill the puddle, like Pacific Arc Welding says, is fill and chill. So you just kind of sit there, get your puddle width figured out, get it hot, and then start running. I typically weld pretty fast. I like to bump up my amps early on and then taper them off to keep it a consistent bead width. That's basically it. Custom made cart setup, and obviously the fixture table's all custom as well. So I just ordered this top as a 1/2 inch thick HRPO and made it 5/8 holes. And I was kind of unfamiliar with fixture tables when I built it, and I did not do a really nice, good square pattern. So it's unique, but it works. Got a nice little swivel seat here, and it's adjustable height. So it just uses a threaded rod. And then I've got underneath it, these are kind of leveling bars. So these are all nuts that you can apply pressure throughout the table if you wanted to flatten it out anymore. It really is super flat on its own. But yeah, this thing's pretty sweet. It's my very first project, learning how to MIG weld. So it's quite the undertaking. But now we're here welding aluminum, so it's done its job and taught me well. All right, we got this thing all finish welded, and it turned out pretty damn good. My welds, I have not welded aluminum in a long time, and it's looking pretty decent. You can tell where my tab and slots are, that I've got an extra material buildup, but for the most part, it's pretty good. So let's go ahead, chuck some water in it, and see if she holds. So the coolant tank holds water. I didn't notice any leaks around the welds, and shook it several times to try and get some extra force on the sight glass area, and I'm not seeing any issues. So I don't think this will have much pressure in it at all. It's just an overflow, so it should be okay. So we know it holds water. I still need to do the fitting up top and the fitting at the bottom, and weld on my mounting tab, and I need some type of overflow for the overflow. So we'll figure that out next. I think I'm gonna get this thing mounted on the car in the engine bay, and we'll determine where this thing is gonna land on the tank. So this just has 2 through holes through the strut tower. I think they used to be capped previously for something smaller maybe. I can't remember what they were, but all I did is I drilled a couple holes where they were already marked. You can very easily get in here, put them on the back side. We got a little bit of up and down wiggle room. Dike them on a Q-tip. The old go-to here. Now this definitely is not great, but it's enough. Should get us in the ballpark, and I'll probably just tack it in a couple of places, and then I'll have it so I can still move it a little bit and get it in its final home. Before I took my tape off, I took a razor blade. You can kind of see it there, so I've got it marked. I know where it goes, but you can see this hangs below this edge a little bit. So I'm gonna go ahead and make sure I have all easy access to this fitting and weld this first. And while I'm at it, probably chuck this one on too. So that's it for the coolant tank. It's all welded and done. You can see it's a bit crooked like that because I don't have my other bracket on there yet. So I think next up I need a bracket to go right here. And this has a little bit of flex in it still. So like I said, I messed up the sight glass on the oil catch can one. So I'm going to try and move forward with this as far as I can without it. And that means doing probably weld this first, and I can weld my fittings on, and I can set up my baffling inside. So that'll use a lot of these pieces here, and this one will just go in like this. So I'll try and figure all that out, and then if I have this piece in here, I should be able to sneak that nut in the inside and tighten the sight glass on, and then put on my final piece on top when I'm done and when that gets here. So well, at least keep moving forward on this and get to a point where we can call it good and wait for the sight glass. So we're about wrapped up with the oil catch can. I've got the main baffling piece done, and that's the correct offset to be able to squeeze in some foam in there. And I've got my plate that'll bolt on here using the nut certs. And I've got 2 lines here that show where this baffle plate will go. So that lines up here in the center. So you've got a little path for oil to travel. And then once that's welded on here, I'll weld this in, weld this on, probably weld the whole back side, and wait for my new sight glass to show up, thread that in, and then I'll weld this side. And in the meantime, I can also weld on my fittings. So these are all from True Focus Fab. Super awesome company. They make some pretty trick parts. One of them being this drain plug here. And you can see it's got an O-ring there to seal it. And then as soon as you loosen it, you know, oil will be able to travel through this MPT fitting and probably out through the fender, I guess. I haven't really thought too far ahead there. I've got a few different options for holes to utilize for drains, but most likely I'll just be able to stuff a can in here and catch whatever oil, or, you know, same for the coolant. I can drain through any of those holes into the fender well. So we're about wrapped up as far as I can make it. We'll see you guys in a bit when I have the sight glass. All right, guys, it's a new day. I've got my replacement sight glass from McMaster, and after some advice from True Focus Fab, these guys are awesome. I've got some additional stainless pad below my foam padding. In addition to all my baffling, this thing should be money. So I'm gonna put the sight glass in, and then we'll be ready to put on our main cap. And then after that, I've got this one additional bracket left that mounts the oil catch can and the coolant overflow together to the chassis. So let's get after it. Well, guys, that wraps up the custom oil catch can and coolant overflow tank project. Got the brackets all welded on and got some fittings on. These are 45s. I think I need some 60s to make it parallel to the ground. And this is a tapped hole from the factory. I can't remember what these 2 holes were. I think I might have had to drill those out. And then this will need a nut cert, but should be pretty stout. I'm gonna weld, I think, the inside of the bottom of this tank to beef it up just a little bit, because there's a little deflection in the tank separately. So, but yeah, got some water in both tanks to do a little leak test. And yeah, I'm stoked. Pretty cool project. All right, guys, that's gonna do it for this video. I hope you got some good, valuable information from it. You got to see my entire behind the scenes design process, from 3D scanning the engine bay to 3D modeling in SolidWorks, and then utilizing SendCutSend to deliver those products in 6 days. Laser cut, bent, PEM hardware installed, and ready for me to weld. Now, if you decide to take what you learned from this video and make your own SendCutSend purchase for your next project, utilize my link below to save yourself some money. That's gonna do it for this video. Thank you for following along, and we'll see you in the next one.